Hello students, I am Dr. Tanmay Vishwash. I welcome you all in my channel Chemistry the Mystery of Molecules. I hope you all are fine. So today we are going to discuss a nucleophilicity order of this halides, because we know the halides are good nucleophile and in many cases we see this thing, and this carbon halogen bond formation is a very important part in organic chemistry. But this case I believe many students get confused, so I shall try to clear the doubts arising here. So I request you please watch the video until the end and your every doubt shall be clear. Now, in the question I have mentioned two words. One is protic and another is aprotic. What does it mean by protic? Protic means there is a OH. You may consider this alcohol derivative or NH derivative. Generally, we don't use ammonia or amine as a solvent, so that's why let's focus on OH. And aprotic means no OH. What do I mean by the statement? For example, acetone. This is polar. Okay, dimethyl sulfoxide. Even you can consider that's a THF tetrahydrofuran like this. It's true. Or you can say very non-polar like hexane. Now there is a problem. For example, we take generally salts. Okay, if you take tetrabutyl ammonium bromide like phase catalyst tetrabutyl ammonium halide, that's a different issue. That's a special case. But in case of normal, for example, let's take potassium salts. Okay, so all are potassium salts. In that case, you can make them soluble by slightly polar solvent. But if you go beyond this thing, they all will be insoluble, so you can't do the measurement. So first of all, remember, if you want to do any reaction, first of all reagent must be soluble, this thing. So that's why polar needed. Better polar is obviously DNSO. It's a very high polar, very easy to deal. Now, question: what happens in case of protic and aprotic? If you look at this X minus, for example, let's discuss X minus, and you are doing the reaction in alcohol or what, those things, polar protic thing. So this is a delta plus, this is delta minus. So this stabilize the anion through hydrogen bonding. I am showing here one example. Okay, I am showing here one hydrogen bonding. No, there are many hydrogen bonding possible. So what is the consequence? This anion is not remain free. It is not free. So consequently, it has to break all this hydrogen bonding. Then only it can attack the Cl. For example, this is the electrophilic center. Actually, since we are in a nucleophilicity order, means better to say this SN2 type reaction. Okay, so this can't attack easily if it is hydrogen bonding. And remember, in hydrogen bonding, the corresponding X minus is stabilized, and along with that, always the corresponding M plus that is also stabilized. Fine. So both M plus and X minus stabilized. Now, let's come to the aprotic. For example, this DMSO thing. This M plus could be stabilized by DMSO by coordination of the lone pair of oxygen. So many coordination possible. I am not going in details. So this is stabilized. But will this X minus will be stabilized? No, obviously there is no hydrogen bonding possible because there is no OH, NH like that. So anion, this X minus is bare, or you can consider free. So if it is free, then its reactivity increases. Second thing, because of this solvent, since this is soluble, so this is also in solution. Since this is solvated, means stabilized, so this is also in solution, so its activity increases. Now, let's come to our main question. This is the background, nucleophilicity order. So in this case, when these polar protic solvents are there, then the softness plays the major important factor. Why? If you look at I minus versus Br minus versus Cl minus versus F minus, smaller the size, charge density is more. Charge density is more, and a tendency to have hydrogen bonding more, because hydrogen bondings are stronger. Fine. So that's why then the reverse thing at this condition, hydrogen bond influence of this reverse thing is iodide is the strongest nucleophile. So in case of polar protic PP, this is greater. They follow the rule. But if you do the reverse thing, in case of polar aprotic, then this I minus, Br minus, Cl minus and F minus, if you look at this, then the stable, then actually anion is bare, cation is stabilized, so anion is bare. So who will act as a better nucleophile? Obviously that atom which have a more electron density go this. So then fluoride will act as a more electron density, so it will act as a better nucleophile. So PAP, polar aprotic solvent. In that case, what is the order? The order is completely reverse. Okay, fluoride is greater than chloride is greater than bromide is greater than iodide. I believe you have understood this. So this is the overall discussion. So please remember the concept. I guess it is very confusing, and if you know the concept, it will be very helpful for you during your examination. So thank you.